My name is Vlad, and I work at 1X Technologies. I'm going to talk about the company a little bit. I'm going to present how we use ClickHouse. I think it's a pretty non-standard way of using it, and it wasn't obvious for us to go this way when we were considering it. But first, what is 1X? 1X Technologies are a company that makes robots. We take aluminum and copper, we produce motors and transmissions, make them into robots, make them into data, make them into AI that then does useful work. We originally founded in Norway. Now we're headquartered in Palo Alto. And currently we're around 300 to 400 employees. We have a bunch of investors. Here's Jensen with our robot, who's giving him the jacket. We collaborate with some companies from time to time. So yeah, and to show you a little bit more, here's a video of our robot. All right, so as I said, my name is Vlad. I am a research engineer who works at AI team in 1X. And here's what we do. We have robots, and we collect data in simulation and in real life with operators controlling the robots through VR headsets. We store our logs in Cloudflare R2. Then we analyze these logs, meaning performing time alignments of each of the robot states, which each of the video frames as precisely as we can. After this, we put all of our data into ClickHouse, except for the videos, and then we train on this. So what did we do before that? Before that, we used this. Our data set was much smaller back then. It was less than 1 billion rows. One row is, think about one row as one frame of a video that is also labeled by robot states, also labeled by language commands, also labeled by anything you can think of in terms of the robot. We don't have voltage there, but anything can be used for AI policy training is in there. The table back then was maybe around 30 columns, now maybe getting closer to 100 columns. So it's like 100 columns times billion. By people who are here, probably it's a small table. For us, it's a pretty large table. And interesting thing about it, when we train, we actually query the whole table, and the query result is double-digit percentage of the whole table, sometimes close to 90%. So it's not just aggregate data, but actual like raw data, like full rows. And we were using Postgres. We were pretty happy with this until things like count with some where statements were taking like minutes. And I'm like, how big is my data set? OK, let's go grab some coffee. And actual queries that we're using for training were taking hours. And you start a query, and you know you're going to train maybe next day. And then you're going to save this and so on. But still, having low latency for these queries is very important for us. And it was highly denormalized. We almost never joined anything. It was a big part of the design so that it's like just easy to query, easy to return data. We started having some issues at this point when it was like hours to get the query, and I was optimizing these things, and I was introducing different complex indices that OK, we're going to have these specific things. We're going to have like a lot of where statements inside our indices is going to be much, much better. And after like a couple of days of optimizing it, I only optimized it 2 times, and we went for a specific query from like 12 minutes to 6 minutes, which is not that exciting. So now I'm going to chat about what ClickHouse features we use. And when we're chatting with the ClickHouse team, it turns out that not everybody uses these features as much as we do. Hope you can find something interesting. First is join table engine. It is a very interesting engine that we use for a very specific task of, all right, we have all of these billions of rows. We have this like 100 columns. And we want to add one more column. But not just add it, but we want to historically backfill all the previous data with some computation. Maybe it is some different database or like some way of computing it, but we want to basically bulk insert a lot of columnar data. Well, the way we can do this, we can say, okay, we have this training frames database, training frames table, and we want to add a column that just has like no default value, just boring default value. And then we want to create a new table using join engine that is joined via UID, and we want to fill it into the temporary table, which is going to be very, very simple because it's a new table, it doesn't have anything. After this, we can join this table with our training frames table, and magically you get a table that actually has these backfilled rows. In terms of how it works under the hood, of course, there is some relaxation time, but the way it looks for the developer is like it's instantly available for you. And that was pretty exciting for us because in our cases, adding a new column and backfilling it with some complex data, maybe you run some neural networks to extract some features and then add them, is a relatively frequent thing. Next thing is we transitioned from Postgres, but only the biggest tables that we had. And we still maintain our old Postgres database for more metadata. It can be more complex tables in terms of we do a bunch of joins there, but they're much, much, much smaller. And in ClickHouse, you can actually just integrate this Postgres into your ClickHouse and query them together, even join between ClickHouse and Postgres, which was really nice. And one thing that is not advertised in the documentation, there's actually an auto-discovery of the schema by ClickHouse. You can create Postgres engine where you specify this captions table, user and password, and you don't really need to specify the schema. And even when you change the schema, I don't know if it's guaranteed, but in my experience, like ClickHouse was picking it up pretty quickly. Next thing is kind of weird, but like reinforcement learning is weird. We have the team who does robot locomotion that allows the robot to stand, walk, bend, kneel, and so on, all of these very complex, very high-frequency motions. It's a very young team, so they were storing a lot of their data in CSV. And also CSV that's distributed in the file system in a weird way. And if you want, you can really put it into ClickHouse extremely easily. You can just provide a file path with wildcards, and ClickHouse will automatically find the schema for the CSV, and will make you a ClickHouse table that you can just query. That is a pretty cool feature that was super useful for us while we were in this like CSV hell. And replacing merge tree. Replacing merge tree is basically a way to have some, not ACID-like, but have some guarantees that you will not have, for example, duplicate data. In this case, we have our training frames table where we featureize our data. And sometimes somebody featureizes things twice. And what should happen is, after you featureize it second time, your old data should disappear, and you should have the new data. Replacing merge tree gives you exactly that with some relaxation time, but with eventual consistency that you're going to have this data. Yeah, of course, we use views and projections. Who doesn't? These are some of our uses of ClickHouse. So I guess it was a very short talk, actually. Yeah, please join us. Robots are cool. And we have a lot of data, and we expect 200x in the amount of data more or less every year. And we did it last year. It was actually more than I expected. It's going to be really exciting to scale beyond that. We're very much looking for software engineers who are really strong in data understanding for AI team. You don't need to need machine learning. We can teach you machine learning. The software engineering is the hard part. All right, thank you. Any questions? There are actually like two directions how it like came to be. Before we hired Dima, who helped us transition eventually, I was really suffering with Postgres. And OpenAI at the time just released the O1 Pro. And I was chatting with O1 Pro of like, OK, we have these pains. And I think like a database is just not doing it. Like, what can I do? Like, I like Mongo. Does Mongo make here any sense? And like O1 Pro was like, no. like, you should try like more columnar databases and like check out ClickHouse. I was like, sounds interesting. Like, can it really be that much faster? And in a couple of months, Dima came over and he's like, obviously we need to do this. So that's roughly the story. We're doing it in batches. Yes, basically like we get a log from the robot, log as videos plus scalar data, and then there's a process of alignment and featureization that batch ingests this into the database. Yeah, so as I mentioned, our table was like very denormalized, and that helped us to transition more easily because there were no super complex queries back then. We actually have more complex queries now where we like join ClickHouse and Postgres together. And the like SQL-like syntax really helped us. I think we didn't use a lot of features that just don't exist in ClickHouse, so just like 2 or 3 things we needed to say, like, okay, you don't do this anymore. Like, this is how you need to do it. It's like, this is roughly how we can do it instead. It was relatively straightforward. Of course, like, you need to correctly choose your index. And like index works like completely differently like in asset databases and ClickHouse. Additionally, some of the data types were not present in ClickHouse. For example, we use 16-bit floats, and ClickHouse supports bfloat16, which is kind of surprising because bfloat16 is very machine learning oriented, but the data loader that we use does not support bfloat16. It supports float16, which is different mantissa and exponent, and you cannot just like transition between them. You're going to lose a bunch of data. So that was a little bit of a pain. Plus, we have some JSON fields, and we just got lucky that we didn't have nested JSONs, and ClickHouse has map, which is basically not nested JSON. I think like mostly it is out of the box. I think we're kind of privileged here that our Postgres tables with this metadata, they're very small compared to this table. Basically, like Postgres is usually like log level data, and this one is more of like frame level data. So like you just have like 2, 3, 4 orders of magnitude less of it. And it is still very easy to just like merge it like in memory. Like I think when Postgres really grows super large, it's going to be an interesting challenge of how you can join between them. But we hope ClickHouse can help us here. Yeah, great question. We do not use ClickHouse for real-time data, actually. Like our usage is like very, I can safely say that I'm pretty sure that ClickHouse developers were not thinking of the use case that we have. We're kind of like doing everything in ClickHouse was not designed for. It just happened to be really good for us. All of this data is training data. It is not real-time data. We have different databases that use like real-time things. Like we have like InfluxDB monitoring. We have other things. I think we all joke that okay, like when you look at Twitter comments, like 1/3 of them are about sex bots, 1/3 of them are about laundry, and 1/3 about them like it's all gonna kill us all. I would not be interested working on sex bots. There are people in the world who are interested in this. I hope it's not going to be our company who does it. Yeah, that's kind of my answer. Not an official answer. Yep, I think it's a natural expectation to have something like this. Like I work in a different team at 1X, and we care a lot about making robots autonomous. But I think people who work on more like companion sides of Neo, where you can talk to it, like will eventually consider this.